very excited to be here. For this talk, I'm going to try to go through all the Flux history, how we got started, all the milestones that we tried to hit with the project, how it evolved, and what we are currently building. So it will be like I'll have to rush through almost 8 years of history. So yeah, bear with me. OK, how everything started is, I think it was 2026. No, it was 2016, sorry. Yeah, so how GitOps started, right? What was the thing that kicked off the idea? It was the battle between declarative and imperative, right? Kubernetes came into being. It was very, very new, but it allows us to think about infrastructure in a different way. Like we come from, back in the day, I did Puppet, I did Terraform, I did a bunch of other things where you always had this third state that you have to keep around. Your systems are not, they don't advertise what they are doing. And discovery was very, very expensive. So you always the best example is Terraform, right? You do an apply and you have this Terraform state, and it's an actual representation of what you think is there, but the drift can happen, so you always have to deal with the third state and manage that, right? Kubernetes, when Kubernetes came into being, it kind of changed this paradigm altogether. The system is fast enough and smart enough to be able to present itself to a consumer. So we don't need to deal with this third state anymore. And this is one of the major enablers of GitOps. Another thing that was happening back then was the pull versus push model. And here we have to thank the Prometheus team and the Prometheus project for bringing a different type of mindset where, because we have Kubernetes and we have discovery of systems, the systems no longer have to push their information to the monitoring system. Monitoring system can use the infrastructure to discover all the endpoints that needs to be monitored. That means less bloat in our apps. We don't need to instrument our apps in a way that the app no longer has to connect to something. The app only exposes some of the metrics, and Prometheus comes and collects them, right? So these two things put together got us to a place where we said we can apply these kind of principles to continuous delivery as well. So at Weaveworks, when we started, we had some conception about this, like, how about replacing kubectl apply with the Git CLI? Everybody knows Git. Everybody loves Git. Everybody is really good at Git, right? Of course, no one is good at Git. But we thought it was. So the idea was, instead of doing a kubectl apply, you'll do a Git push. And the same thing should happen, because the magic of Kubernetes, declarative, we can have the agent that does all these things. It didn't turn out that great, because it's still tough, even today, to deal with Git. But that was one of the initial ideas. Another thing that we thought it will work fine is once we teach developers Kubernetes and Prometheus, they will love doing operations, right? They will love doing YAML and all that stuff. I don't know. Maybe 1% of them do. But those were the premises. So this is how Flux version 1 got born. The concept of the naming of GitOps came after Flux was a thing inside Weaveworks. During these years, it was a niche thing. No one actually knew what GitOps is. We were trying to talk about it. And I wanted to talk a little bit here at this stage around Flux 1 and what limitations we had back then into Flux. First of all, when we started, there was not even a Kubernetes deployment. We didn't have the deployment object in Kubernetes. So we didn't have CRDs. We didn't have custom resources, right? So Flux version 1 was a simple daemon, was a pod running there. you set up the pod, you configure the pod with where is your Git repo, you mount the SSH key, and the whole idea was one Git repo, one cluster, and that's it, right? And the whole orchestration will go like that. And it worked for a couple of years. Because Kubernetes was very new, you wouldn't deploy hundreds of thousands of apps, you wouldn't have thousands of nodes, and so on. But this limitation came early on into being, like people were saying Kubernetes was getting mature, Kubernetes was getting CRDs, people were starting using it more, so the limitation of having a single repo connected to a single cluster was a major limitation in the Flux project. Another thing that we've built early on was image scanning. We were scanning all the images in the cluster, and we were upgrading all the images in the cluster. You know what? Back then, Docker Hub had no rate limits. Things have changed. Try to scan all your images without image pool secrets, you'll see. And probably the most important thing was that we thought that Git was the desired state, but in fact, Git is not the only thing that tells the cluster how it should behave. There is also the container registry. So the desired state here is actually split into two things. You have your configuration in your Git repo, and you have your actual containers and workloads running in the container registry. And these two things have to be always in check. So we say that GitOps, yes, everything is in Git, everything is declarative. Well, is not actually 100% true. Right? It's always this concept of the container registry. So the desired state is kind of in shift here. To overcome all these limitations, in 2020, we started version 2 of Flux. Me, Hid, and other maintainers back then, we decided let's spend some weekends and figuring out how to work with controller runtime and how to basically rewrite Flux completely, but keep the GitOps idea alive. Right? And usually, for big projects, version 2, a complete rewrite, doesn't really work. Most version 2 projects fail. Like we are here, this is proof that we actually managed to do it. We managed to rewrite all of Flux. People loved it. We have increased the community a lot by doing it because we split Flux into many controllers, which are very dedicated for what they are doing. So if you know Git very well, you can go into the Flux project and contribute to source controller. You don't have to understand everything. So by having Flux into these dedicated controllers, we enable the community to contribute more and be less fearful. In Flux version 1, everything was a monolith, right? And when you touch a monolith, any change that can make can influence another thing in the controller, and everything can blow up. With this design, we have enabled our community to help us. And we were seeing like Flux version 2 hit 1 billion downloads of the container, like really fast. It was crazy. I mean, I really loved those early days. A lot of weekends spent on that. I have no regrets. It turned out great. And one of the things that we realized with version 2, we need to have a better user experience for getting started. GitOps is actually hard to, also as a concept, you need to change your mindset, you need to change how your organization thinks about continuous delivery. And we came out with this idea, we should have a command called Bootstrap that does everything, creates the Git repo for you, connects to the cluster, installs Flux there, does the handshake, we generated all the SSH keys for you, and it's also enabled another part of the Flux community, the part of people that are running Flux at home. And early on, we optimized Flux to run on Raspberry Pis. We actually made Flux be extremely lightweight. If you install Flux today and you deploy your home apps, you'll see the whole Flux system will use 40 megabytes of memory and none of the CPU. And it was optimized from the beginning to be able to run it at home, right? And that enabled us later on great things like a bunch of large organizations are running Flux at the edge today. And why they can do it today? Because early on, we had this great community of running Kubernetes at home that adopted Flux and helped us optimizing it. We had all sorts of issues. It uses too much CPU. It shouldn't be like that, right? So we early optimized, which is also
Multi-arch was a pain.
Multi-arch, yeah. Just building for R32. That was like, yeah. But it really helped, starting the project with all these constraints and have a demanding community around that edge use case that later on turned into something very great. Another thing that we've built on top of Flux, you do GitOps, it's great. You push a new version of your app, and that gets deployed on all your production clusters. Well, the problem is, what if there is a bug there? If there is a problem? Flux will do its best job to deploy everything everywhere, so you'll blow up your whole production estate, right? So we've built this project called Flagger, which it was the first ever implementation of this progressive delivery idea. Red Monk came up with this name. The idea is Flux deploys everything in production, but the actual release is not made by Flux. It's made by this other controller that shifts traffic slowly, your production traffic for the old version to the new version, measures, error rates and everything like that. And if something goes wrong, you can set up SLAs and SLOs, and it will do the automatic rollback. Then another idea we had was, once we built Flux version 2 and we had source controller, the first implementation for the desired state was, of course, Git. But we think, now that we have a source controller, what if we go beyond Git? It's GitOps, you still work with Git, you open pull requests and so on, but that doesn't mean Flux has to connect to the Git repo in the end in your production clusters. So we collaborated with the Open Container Initiative. OCI Artifacts were getting more supported by more registries. Not Docker Hub at the beginning, but cloud vendors got into the OCI Artifacts very fast. So we come up with this idea: what if we unify the desired state into the container registry? And this comes with many advantages. You have a single source of truth for apps and configuration. You can sign them with cosign or all the signing tools that you are currently using for your container app images, which will also work for configuration. And this also gives you a better way of running production systems where Git, your GitLab instance, your GitHub.com, those things no longer are part of your production system. If those goes down, your clusters are still reconciled, your clusters are still doing drift detection and so on. And this also helps the edge use case, where at edge you don't want to connect from all these disparate distributed devices back to your Git instance, which can be very far from those. You must have some kind of regional container registry already for pulling images, so you can reuse that for configuration. And here I'm talking about configuration, not only Flux configuration, but also Helm charts. For Flux configuration, we have a Flux push command, and for Helm charts, you know very well, you can do, Helm can also target a container registry. So all these three technologies together allows us to unify and say, we have a unified storage for doing continuous delivery. And 2 years ago, when I joined ControlPlane, we said we need to make Flux sustainable. How can we make Flux sustainable, right? We need to sell something. We need to make money out of it. How can you do that, right? And the idea was to make an enterprise distribution for it that gives you all kinds of assurances. It's the Red Hat model. We give you 24/7 support. We give you 0 CVs and so on. And once we talk to large users of Flux, we figure out what are their challenges. And one of the major challenges was we have 200, 300 clusters. We want to upgrade Flux everywhere. We want to set up Flux identical everywhere, and so on. So you need to do operations on Flux itself on hundreds of clusters. Storing this into your Git repo, the Flux manifest 200 times is not that nice. So we built Flux Operator, which is an open source project. Anyone can use it. It also enables us to ship the enterprise images. And what Flux Operator does, it comes up with this declarative cluster Bootstrap. And over time, we've built a bunch of APIs on top of it. This is how a Flux instance looks like. So you can, by creating this custom resource, the Flux operator will know how to configure all the Flux controllers and also do the initial sync. And here you can see I'm syncing the cluster state from an OCI repository. So Flux operator is OCI first. You can point it to a container registry, and it will deploy Flux, set all the syncing from there, right? And you can fine-tune Flux however you want using this simple configuration. Of course, it supports what we are now calling Gitless GitOps, and we published a white paper around how you can actually adopt this new technology and move from Flux Bootstrap to the operator using all our open source tooling, and have this unified storage with attestations and everything in there. Another thing that we have developed is this resource set API, which allows you, we try to solve one of the biggest requests in Flux. So the problem was you open a pull request, you change something in your configuration or in your app. And the way Flux works, you have to merge that pull request in your main branch or whatever branch you are syncing, and only then Flux will deploy it on the cluster. And people are saying like, okay, but traditionally with CI, when you open a pull request, you can run your test, you can build the image, right? And we want this kind of user experience for Flux itself. And with the resource set, what we did was we allow you to use Flux operator, scans your pull requests, and can create ephemeral environments. With Cluster API, can create a new cluster, deploy everything there, test it. Or if you have dedicated preview clusters, you can create ephemeral namespaces. And the way it works, you open the pull request, everything gets deployed. Flux operator then posts a comment with, yes, the things work. Here is the URL for you to test out or run your end-to-end tests. And once you merge it or you close the pull request, Flux operator will destroy this ephemeral environment. So you're not left out with using compute. And we've seen a major adoption of this workflow. And if you are using Flux right now, I really encourage you to check out this feature of preview environments. I think it will help you, give developers and SRE people more confidence into fiddle up with configuration, because now you can do it without having to merge things in a cluster which should not affect anything running in production. And of course, AI, right? Everybody. You have to do AI, otherwise you are. Yeah. So we've built a Flux MCP server. I think it's 8 months old, something like that. It all started with the desire of, can we use AI to troubleshoot Flux? That was the main thing that we want to achieve. Yeah, it turned out to be super useful for many other things. Once we start, working on it, adding more tools, we found out that we can do cross-cluster comparison. This is yet another thing very hard to do, because Flux is distributed. Flux runs on every cluster, you have hundreds of clusters. How you figure out if there is a difference between, production in this region and another production cluster in another region? You have to go through all the customized overlays or your Helm chart values, do comparison. It's quite complicated, and because there are various repos and the configuration can be distributed towards your Git estate, it's even harder to do this kind of operations. It turned out with the MCP server, we built specific tools inside, so we can say, compare my Serve Manager configuration from this cluster and that cluster. And what the MCP server does, it discovers all the clusters in your kubeconfig, knows how to ask Flux, hey, where is Serve Manager? Where are you deploying it? Here it is. Give me all the configuration. Then it does a diff, and it gives you a really nice and compact report of those changes. It's really, really useful that way. Another thing was you have Flux dependencies. I don't know if I'm hoping you are using that. It's really great for, when you spin up a new cluster to say, I want policies first, then after policies, I want, service mesh, ingresses, and only then apps, right? So you have this Flux allows you to define this dependency tree, which is really nice, but when you need to debug it, it's quite hard to understand. Once you add a bunch of dependencies everywhere, how can you make this mental model of who depends on what, how it gets deployed, and so on. We've built some tooling in the MCP server that can actually draw in real time a graph of all your dependencies by just looking at the cluster. And it's very, very fast. So that's another great use case of the MCP server. It turned out is really good at explaining what's happening and how the delivery pipeline runs in your cluster or across clusters. Because now you can compare the dependencies between different regions, dev versus staging, and all that stuff. But going back to the original idea of how we build the MCP server was around debugging. And here is an example of a developer opens a pull request. Let's say it uses VS Code. Copilot writes all the code, vibe coding, open the pull request. We don't know what's in there. Doesn't matter. Flux Operator sees the pull request, waits for CI to build the image, deploys this in a preview cluster, maybe with a generic Helm chart from your organization. Then Flux Operator comments on your pull request, everything failed. Okay, Helm release timeout. Great. Now what? You have to do kubectl digging. Well, instead of doing that, you can just copy-paste the error from the pull request, throw it into Claude or Copilot or whatever your LLM is, which is connected to the Flux MCP, hit enter, and the Flux MCP will actually tell you what's going on. Because it can tail logs, it can look at network functions, it can do a bunch of analysis and give you, we did some experiments with Mateus where if you hook up the GitHub MCP or GitLab MCP, it figures out what the mistake is, and it can open a pull request against your pull request with the fix. So it can actually go through all these stages, and of course, it's not perfect. The fix can be a hallucination. You merge the fix, it crashes again. But it's an iterative process. I mean, if you do vibe coding, why wouldn't you do vibe debugging? It's like it's right there. It's yeah. Okay. Okay. So since we started with Flux, we said people that are using Flux have to be Linux people. You need to use the command line. You need to love the command line to use Flux, right? The CLI is the greatest things we have, and we've built like hundreds of commands in the CLI, and you need to be, a geek to use it. And yeah, not having a UI was always a big problem commercially, and all the time it was like, but Flux does not have a UI. I want to click things. They're like, no, use the command line. Now we are even better because the MCP is like, knows everything that the CLI does, right? So you can actually talk to your clusters and so on. But still, we don't have a UI until today. So, yay. There is a pull request on Flux Operator, so this is not merged yet. We need to put more vibe coding into it. The idea is the next version of the operator will come with the built-in Flux status page that will show you everything Flux. It has a mobile view as well. You can search all the things. You can do eventing. It will tell you what's going on. You'll be able to copy-paste here and ask the MCP how to fix it. We are also thinking about the status page should create prompts for you, so you don't even need to think about how to write your prompt. It will give you the prompt, copy paste the prompt, put it in Claude, and right? But we have a UI, right? So one thing I want to tell about this is like, we are never going to allow you to modify the cluster state from the UI, I'm sorry. Like, this is read-only. This is why it's called status page. Flux is still Flux. We are not going to the ClickOps, GitOps mixture. You'll not be able to exec into pods. You'll not be able to delete stuff. The MCP server can do anything and everything. So if you really want to do Vibe DevOps and let the MCP go wild, delete all your nodes, stuff, you can actually do it. There is a flag, read-only. You can remove it and go wild. But the status page is just a status page, and we are going to develop this UI going forward, and it will be only about figuring out what's going on and help you guide you towards a solution, not actually doing things in the UI, clicking things. So I know some of you may be disappointed. You want to, exec into pods, see the pod logs in the UI, what Kube Dashboard does, Argo, and others. We don't think that's the right approach, and thinking that we already have the MCP that can already do all that stuff, I think it's a better solution to use the MCP and not have the UI into a full-blown thing that, all of a sudden is a cluster admin. Anybody can, if someone hacks your ingress and it gets to the UI, can do really bad things. We don't want that, right? So the UI will stay read-only, but yeah, I hope this will, solve the. You don't have a UI. No, we have it. It's there. Getting there, yeah. Vibe code to the death. That was me. Thank you very much.